Cool. Hi guys, good afternoon. I'm Ankit. I'm the founder of deployment.io. So we started this company around 8 months back, and we are on the mission to make it very easy for developers to be able to deploy on the AWS cloud, right? So I'll talk briefly about how we are using Go to design a very high performant deployment engine. Right, so what features we are using in Go and how y'all can also use it in your day-to-day life, right, while coding. So like when we started the design, right, so we got a lot of inspiration from other systems like Kubernetes and other deployment engines. So our deployment engine consists of two parts, right? So one is a data plane and one is a control plane, right? But the difference here is that the data plane is deployed on the user's cloud, right? And the data plane has all the access to the user's cloud. So we never in that way collect any keys or those kind of things, which can cause a lot of liability and issues for our users, right? And the control plane is something which is hosted on our cloud and takes care of authentication and allocation of jobs and all those kind of things. So yeah, so briefly stating that the data plane basically checks out the code, builds the code, it basically creates previews, deletes resources. So in many cases, developers would by mistake keep resources there even if they are not needed. Right, so we have automated ways to deploy resources when you're not using certain kind of systems, right? Suppose if you have a huge Kafka cluster, right, and you're just using it for testing, and someone forgets to delete it, it'll be a big issue later, right? And after a month, the bill will show in some AWS account, and then you'll feel the issues later, right? Right, so obviously, I spoke deeply about concurrency in the previous session. So concurrency is one of the best features of Go, and we use it extensively in our system to make sure that we are able to run a lot of jobs concurrently. Right, so suppose if you have, because see, deployment is something that it's very, very system critical, right? If suppose a bug goes in, you want to make sure that your product is deployed ASAP as soon as it's fixed, rather than some system that takes like a lot of time to deploy later, right? So we use concurrency extensively, and it's so I think it was covered very, very this thing in a lot of detail, but I would just add, what our thinking is basically, it's, when you are designing a system, you design it in such a way that you design different parts of the system that can be run concurrently, right? So so that's how it's different from parallelism, where it's actually running parallelly, but in concurrency, it can run parallelly if you have the resources to run it parallelly. Right, so it's a design concept versus the execution concept, right? So concurrency is a design concept, right? And so along with that, we also use a very, very little known Go package. It's called GORPC, right? So one of the big advantages of using GORPC is that it's a binary protocol, right? So your structs are directly serialized into binary communication between processes, rather than using JSON or REST or something like gRPC, right? So this is very, very native to Go. So one disadvantage is obviously you're stuck with Go, right? So moving to some other technology can be a bit tricky, but for now it was really for us to move fast, and this was really helping us to do that. Okay, so concurrency again is like one of the big advantages of concurrency is that it helps you use the multiple processes that are there, and most of the systems now have multiple cores, right? So even when you look at any new processor that is coming out, they always say that okay, we are increasing the number of cores, but individual cores might not have that much performance, right? So that really helps when you're able to run all these processes in a concurrent manner, and different cores take care of executing many different parts of your program. And other thing is, obviously it was briefly discussed related to system calls, and IO is one of the biggest calls that is made, right? Because obviously a lot of networking calls are made and you are hitting all those APIs and stuff, right? So obviously when you have when you write a program in a very concurrent manner, so you're able to make sure that your cycles are not wasted, your CPU cycles are not wasted, and your system is always executing at top performance. Right? So how we use concurrency is that obviously like we're able to run a lot of these jobs concurrently and are able to make sure that even if you have some rollback job running along with some new deployment going on, we are able to run them together. Right, so there are two major concurrency primitives that we use. So Go routines obviously is a way to start a Go routine, and channels, we use channels extensively for communication, and so channels are very, very lightweight, and you can have like thousands and thousands of channels in your program. Yeah, so obviously like, it's very, very easy to start a Go routine in Go. So coming from Java, like I was very surprised when I was learning Go around 10 years back. In Java running a thread was a pain, but in Go it's just a very simple keyword. Any function can be turned into a new Go routine by just the Go keyword, right? And it's analogous to OS threads, but it's very different as we discussed in the last session, right? So OS threads are very, very expensive. Go routines are lightweight. So I remember in Java, like we used to make sure that there's an upper limit to the number of threads we could spawn, right? Because a thread was very expensive. But in Go, you can just start a Go routine and don't worry about it at all, right? Because you know that the Go scheduler and the compiler will take care of it for you. Right, so one great concept about channels is that you are sharing memory by communicating, right? So you don't need locks or mutexes in that case. Okay, so there's one other way to share memory, like when you have those mutexes and you synchronize and make sure that there are no race conditions between the two Go routines. But channels takes care of that, and you can really design systems in a way that makes a lot of sense. Like you think in terms of passing data between two Go routines rather than sharing data between two Go routines, right? So it makes a lot of sense when you have some function returning some data and you want to pass that data to some other function running in a different Go routine. So you can use channels extensively for that. And so these are some like different primitives and different functions we can use for channels, right? For passing data in, for making a new channel and closing a channel, and like passing data there, yeah. Right? So GORPC is something which we use to communicate between the data plane and the control plane, right? So this was actually very critical for us because a lot of jobs are allocated in the control plane, but the jobs are actually executed in the data plane, right? So we wanted to make sure that we don't use something like JSON where it's a string protocol. It requires a lot of serialization, deserialization to go primitives like structs. So we wanted something like, could be a binary protocol where at least we don't have to worry about the size of the data also, right? Because it's very, very optimized and you can compress it also, right? And it supports TLS also. So we use TCP on TLS. So other thing is that this uses TCP. This is not HTTP, right? So even though HTTP is on TCP, but this directly uses TCP, and there are some advantages related to that. It's lighter than HTTP that way. Yeah. You have a question? Yeah, go ahead.
So, you mentioned you are not using GRPC, so like any particular reason why you are using or not using GRPC? Because GRPC serves the same purpose as
Yeah, so see, gRPC uses, you need to have that protobuf and all that, you need to design, right? So that was a major reason we didn't use that, right? Because we thought like at least for the next 1 year we are going to be with Go, and if we need to use something else, we'll figure that out later. So again, gRPC, it wasn't a performance decision, it was more of a, to get it done fast, right? So both our control plane and our data plane are written in Go. So we thought, okay, let's take that decision and get the product out faster. Right? Otherwise, gRPC is another, if you have different languages, like if you want to use Java and if you want to use Go, or if you want to use JavaScript and other languages, then gRPC is the right approach in that case. Performance-wise, I would say that both might be similar in a way, right? Unless like, I think gRPC supports TCP and HTTP both, so that is one of the difference. Like GoRPC supports only TCP. Yeah. Yeah. So I think gRPC use HTTP or HTTP2 also. Yeah.
So if given a chance again, you will consider gRPC?
No, again there are trade-offs, right? So performance-wise both are similar. So if suppose I am using Java, suppose if I feel that okay, if I use Rust, suppose, right? So that could be in the future, like after 1 or 2 years, I feel that okay, Go is not scaling for me, and I want to use Rust because of the obviously memory management and garbage collection or whatever, right? Then I might think about gRPC, but then that's a huge big project, right? Turning it into that, but if you have to do it, we'll do it. But right now the decision for this was performance plus getting it out fast. Yeah, so any other questions? Yeah, so when obviously you can take a picture of this, and once you go home you can check it out on your laptop. So this is an open source. So I was when we were testing with gRPC, that I open sourced this project, and I'll be talking about this, and we can do a demo of this. You can see the code properly, right? Yeah, 1 second. I'm used to 2 hands, so what's the problem? Is it better? Yeah, so we have a client and a server, right? So it's a simple client server model, right? But the difference is that it's not some REST server, or it's going to communicate using gRPC, and we'll be doing remote process calls. Right, so this could very simply be on different servers also. Even though it's running on my laptop, both of them are running on my laptop, the client, so it could be used for different microservice communication also, right? You have 2 microservices in Go, and it could be across the network, across the internet, on an intranet, anywhere, right? So we can go through the client code first. Yeah, it's pretty self-explanatory, but I will talk about things that are different. Right. So as I mentioned before, you communicate using structs, right? So think of args. So if I want to talk in terms of JSON, suppose, right? So think of this as request body or something, right? In your JSON, when you are hitting the REST APIs. So args is a way to send data from the client to the server. Okay, and quotient again is basically a way to receive data, right? So args are used for sending data, and quotient is used for receiving data from the server. So I think I'll go to the server first. Okay, so one condition is that the server also needs to know about these data types, right? So you can have it in some shared library or somewhere where these same data types are used by the server and the client. So we have defined it again, but it could very easily be in a different file, which in a different package also, it could be shared. So arith is a way to send data. It's a type on which we call these functions, right? So multiply on the server is a way to, so the client can call the multiply function or the divide function on the server directly, right? So this is how we are defining the functions that can be called on the client or called by the client on the server. So how we do this is, in your main function, you basically, this will be on the heap, right? So you have this arith, which you basically allocate in the server itself, and then you have to do an RPC register of this arith type data, right? To basically tell the server that this can be called by the client. Any function on arith can be called by the client on the server directly. And it's like basic stuff where you are actually starting the server on port 1234, and you start listening, right? And then it's directly you can actually accept connections here, and then you can use a different Go routine to execute that request which comes from the client, right? Very simple code. I've kept it simple on purpose, right? It could have been made very complex, but very easy to understand. So this is how you define whatever capabilities your server wants to give to the client to execute, right? So any questions, just let me know if you have any questions about the code also. And then let's go back to the client code. Over here we have obviously the main is there, then we take the local host and 1234 server and port from the terminal, and so it uses the TCP protocol and it directly creates a connection with the server, right? So over here you can see that, like it's similar to how you can create a JSON body. We create arguments. Okay, now I want to do, I'm passing A as 17 and B as, so I want to do, division between the two or multiplication between the two, right? So I'll pass 17 and 8, and then reply is a way to get the data back from the server, right? So integer we don't need to define because it's a primitive data type, right? Then obviously you can see wait group here because we will be calling it in a different Go routine. So yeah, this is a very important line. So you can see that we are directly calling that multiply function, right? The client is directly calling the multiply function here, which is on the server. It's passing the arguments and it's basically waiting for the reply. So one important thing over here is that you have to pass it as a pointer. Okay, the reply has to be, or whatever data you want returned from the server has to be passed as a pointer. And you're just printing the results, right? So similarly, the main routine is doing a division, right? And we saw that this quotient is defined in the server also and in the client also. And we are doing a division, and again 17 divided by 8 because you're passing the arguments, and you get the response in the quotation. Right? So we can just execute it and see what happens. Okay. So I've started the server and I'm passing localhost and 1234. It's on the same machine, that's why. Right? So you can see that, okay. So this is coming from the server, right? So 17 divided by 2 and remainder and multiplication, right? So any questions you have about the code, or if you want, like to know how we can make it more complex and all, we can discuss that. But that's the basic gist of how GORPC is actually working under the hood. Right, so that's all actually. So if you have any questions about this, or even like Go routines, concurrency, anything, you can just like go ahead. Yeah.
Ankit, can you open the data?
This one? Yeah.
The data project itself, on the comment app. So while building this or developing this, what were the most convoluted or the most challenging part you faced, and how did you help you?
See, I think one of the most challenging parts is, see, deploying on your cloud is easy, right? But being able to deploy on the user's cloud is the toughest thing, right? Because the runner doesn't have much control, like, to be honest, right? So obviously, like, once the code is deployed on your infra, you have a lot of control and observability and all those things you can add, right? But when the code is running on your client's infra, right, it's very difficult to manage that kind of code, right? So updates, auto updates, right? If there's an issue, the runner should basically be able to tell us, like, okay, there's an issue, just tell the client that some issue has happened, right? So more than coding, that was the big challenge, coming up with that architecture that could help us in solving those issues, right? So that was obviously one of the big challenges. And other challenges, in the startup, there are challenges every day, right? So technical challenge, this was the challenge, I would say. And this is a challenge we could face in the future also as we add more features and as the product becomes even more complex, right? Yeah.
So where is the stage 2 of the deployment basically?
So
you say the infra is the state, and what is there? This was, this is put up, this has been put up, and how you reconcile that within your code?
So you're saying infra is what? Sorry, I didn't get that question.
Suppose like your requirement, okay, I want to create these EC2,
Right.
containers, I want to
Yeah, so I'll give you a brief demo of the product. I think that's because I'll tell you exactly what we do. Let's see how I've done it. 1 second.
And how do you reconcile that within your code, right? You have to see there will be some deltas, right?
Right. I'll just tell you exactly
Where
what we
is the
do.
state stored for that delta, and how do you reconcile it? Because if you look at it, you can hash it up like Terraform, and
Right.
it doesn't say anything, right? And it's looking how it is.
Right. So
Because that doesn't go.
right. So I'll tell you what we do. So we have a runner and a control plane, right? So when you talk about reconciling, so what we do is you can think of it as a PaaS system, right? So we won't directly deploy an EC2 instance for you, but we will deploy a static site for you or a web service for you. So it's a developer platform. You can think in terms of something like Heroku, but enables you to deploy on your own cloud, right? So we reconcile on the workflow level. So we can say, okay, this is the ECS cluster that is deployed, or this is the EKS cluster that is deployed, and this is the name of that cluster, right? And this is the deployment on that cluster with this particular service name. So all those things we reconcile, right? So we don't reconcile at an individual infra level. We reconcile at an entire workflow level. So I'll give you an example. So suppose you have this React.js app deployed, so the demo account. And this now, suppose if you want to deploy a new service, right? You can directly say, okay, I want to deploy a static site. Then you can connect your GitHub repository, right? You can say, okay, I want to suppose deploy Golang, or I have to deploy React.js, right? Then you say, okay, deploy. And then you can just say, okay, this is the branch I want to deploy, this is the name, and this is the npm run build or wherever my code needs to be, and you just decide the environment, right? So it's not individual infra level infra that we are dealing with. So under the hood we do that automatically, right? So currently we support ECS and Fargate, right? And for static sites we support CloudFront and S3.
How about Amplify?
So obviously, like, it's right now we have started, so it's you can say it's similar to Amplify in a way right now, but it will become much more complex. Something you won't be able to do with Amplify, right?
Any more question for Ankit? How about you just picking up on location taking for running the garbage collection, right? Are you giving a marketplace if you are not mistaken? This is
Sorry?
Your total is already part of AWS marketplace, right?
Yeah, it is.
So
It is.
they must have run something to make sure it's efficient in terms of garbage collection and all that. Because they're running on.
Yeah, so see, there's one point I will note for garbage collection, right? So there's specifically one thing that we do to make sure that we use a lot of pointers, right? So our code has become very, very complex. You can see that, right? So what we do is instead of returning pointers, we pass pointers as parameters. So for example, now if suppose you want to pass an entire struct, or you want to return some struct from a function, right? So instead of returning a pointer to a struct, we'll pass a pointer and then we'll do call by reference. in the sense that in that pointer you'll add data, so automatically that data is passed, and then it will be on it will help in garbage collection, and in some cases escape analysis will be done, and Go won't even put it on heap. Okay, yeah.
We have from online.
Okay.
Question is deployment type a CSV tool or more IAC like Terraform or something? As you also mentioned about this.
Yeah, so we have combined the two. To be honest, and obviously with AI and all, I feel that eventually a lot of these things will be done by AI, right? And we have an AI tool also coming up soon. So we have combined ISE and CI/CD in a way, but we'll design it in such a way that you could use other CI tools also. So if suppose you want to integrate with GitHub Actions, or you want to integrate with Jenkins, right? Because we don't expect people to change their existing flow for us, right? So if you're using GitHub Actions, and you want to use us as a CD tool, right? Use GitHub Actions, you push your image in either GitHub registry or Docker registry or wherever, right? We'll be able to get that image directly and deploy it on your cloud. So suppose if you want to deploy a web service, right? And you have some Go code written, GitHub Actions say you're pushing it to registry, and then from that registry, we pick up the Docker image and deploy it on your AWS or GCP or whatever we have support for.
Developer type will have this CCI tool as well, right?
So CCI means what?
Like you have to build. Does it build or something?
Yeah. We do building also. So either you can build through us, or you could push a Docker image also. Right, so that there will be two ways. So I have it in development. Once I'll need to start the server and everything. Okay. So basically, there are two ways, right? One way is in a CI tool. What you do is you are building the product, building the code, and you are pushing it to some Docker, right? So mostly everybody is using that. You're pushing it some Docker registry. Either you use ECR, or you use Docker Hub, or you use GitLab, or you use GitHub, right? So that's one way. You're pushing it there, and some CI/CD tool is getting that image and deploying for you on the cloud, right? That's one way. Second way is you do the build also, you push it to ECR, and then you deploy. So we support both. Right, so if you want to use us as a CI, you can use us as a CI. If you have GitHub Actions, you'll be able to use that also. So in the future, like we support GitLab, Bitbucket, and GitHub. So, yeah. Any other question? I don't know. Did that answer his question?
Another question coming from is like, how does RPC manage HTTP collection for you?
How is
RPC managing HTTP collection for you? How is that?
So that is happening internally, basically. Go is doing that. Like the standard library does that internally, but you can look at the source code and everything, how it's happening. So we are not doing it on our own because it's at a bit higher level. So it's not like pure. It's creating the connections and it's maintaining the connection actually. Right, so think in terms of HTTP2, where you have the connection and then you are, multiplexing that connection. So similarly, it can happen.
But I don't think it's doing HTTP, not TCP.
No, this is TCP. But think in terms of HTTP2. I'm saying, just to make it easier to imagine. Right. Yeah. So in Zoom mode, 1 second. Where is it? Zoom. Man, I don't like Zoom at all.
Okay, you can ask the question.
Who asked? Like, where is it? You can say the question. Yeah, what is it? Achha, start. Cool, thanks. Okay. CI/CD done, right? No other question is there. Cool, yeah, that's it actually. So you can check out the repo over here, right? So we have actually open sourced the runner. So I can show you the code also. It's too complex to cover right now, but yeah.
Is there an architecture diagram for this? How is it doing something like a code versus?
Yeah, so this is actually the source code. This is open source. So architecture diagram is basically the entire system architecture is there. It's there in the docs. But this is like purely written in Go. You can check it out. You can, contribute. That'll be amazing, right?
One more thing is like we know about Jenkins, Sambo and everything, right?
Sorry?
Do you hear me?
Yeah, now. Yeah.
So just want to know, like, is there a differentiating factor in this that I was having it compared to Bamboo or some other that we
Compared to?
Bamboo.
See, Bamboo, if you think about Bamboo, right, it's something like Jenkins, right? So it's not a lot of learning curve is needed there, right? So in our case, you can think, see, our biggest differentiation is that you don't need to learn cloud, right? So as I mentioned, if you look at the code, look at the product, right? If you know how to deploy Node.js on your local laptop, you should be able to deploy on AWS, or you should be. So we are working at a higher level of abstraction than the cloud, right? So you can think that we have abstracted the cloud infra away. So you can have GCP, you can have DigitalOcean, you can have AWS, you can have any cloud under the hood, because you don't care, right? As long as you're getting adequate memory, CPU, or you're getting adequate disk storage, you don't care about the cloud under the hood, right? It's like, think in terms of my laptop, right? I don't care whether it's getting charged by Tata Power or Adani Power. Right, similarly, so that's the whole vision of the product. So if you think in terms of Bamboo, you have to learn the underlying cloud and then you have to deploy, right? कि EKS पे कर रहा हूँ, ECS पे कर रहा हूँ या GCE पे कर रहा हूँ, wherever I'm deploying, right? So that we are not. So that's how it's different, right? So you don't need to. It's a very subtle difference. Only some people understand, but it's there.
So currently, what else clouds do you support?
So we support AWS for now, but obviously the vision is to support others later. But AWS has the highest market right now, so we're starting with that.
Any question for Ankit? No?
Like for the initial setup, right? So like into even if we're supporting cloud, we need to do an initial setup, right?
Right.
That we have to do, right?
Yeah. So I'll just so that's where the data plane comes in, right? So if I tell you, so we have a concept of runners, like so data plane, right, which is the open source code. Now if I want to create a new environment, so as I said, right, we don't collect any cloud keys or anything, right? So what we do is, so you can set up a new runner. So either you can run it locally on your machine. Think in terms of Terraform, right? So Terraform, when you're setting up infra using Terraform, you need to install the Terraform client on your machine. You have to give your cloud access to it, right, to create the infra. Right. So similarly, you can have a runner which is also written in Go, by the way, right? Like So it's similar to Terraform. Suppose if you want to deploy a static site on your AWS account, you just give it a CloudFront and S3 access, right, locally, and automatically through GRPC, through GORPC, it gets this job and then executes the job on your cloud, right? So other option is you can use an AWS setup, right? So we support. You can use a CloudFormation template to deploy the runner on our AWS account, right? So those are the two aspects. So this is the one-time setup. So after this, you don't need to do any. You might not even need to log into your console, AWS console again.
Any more questions for Ankit?
And I'll just say one more advantage, right? So many times, what happens is you want the dev environment and the production environment on different AWS accounts. So in that case, you can set up two different runners, right? So we support multi AWS accounts also, right? So in the future, when we support GCP runner, you'll be able to have like one runner running in GCP, one runner running in AWS, and then you can have the same code deployed in both the places just with one click.
When I'm deploying, the first thing will be go to the runner, right? And the runner will deploy my code in this case, right?
Exactly. So think of runner as a DevOps engineer in a way, right? So you have a runner which is on your cloud, right? You say that, okay, I want to deploy a static website, right? So it will pick up the job, it will execute the job on your cloud, right? You say, okay, now I want to delete some infra, right? It will automatically say, okay, delete infra after this time, delete the infra. if you want to say, okay, I want to create some previews, right? It will create a preview and delete a preview later. So it basically executes the DevOps jobs or the deployment jobs or infra jobs.
So the runners are like continuously, like they are in a they're taking my AWS resource, right? It's continuously running, or whenever I'm triggering at that point.
So yeah, so good question. So we auto switch off the runners, right? So we auto switch off the runners when they are not used. So we don't use Lambda though. So there's like around $4 per month kind of cost. So we have a controller that will actually switch off the runner. It times out.
And like this runners are synchronous or asynchronous?
Which one?
This runners are synchronous or asynchronous? Like I can deploy multiple at the same time, or do I need to like
It's
synchronous? You will
so I'll tell you, under the hood, it's you can think it's a Fargate task, right? So you can have multiple runners running parallelly also.
So for example, suppose I want to deploy multiple of my projects at the same time, right? So that
Right.
To achieve that, do I have to deploy multiple runners, or I can use one runner? And
Yeah, so one runner, obviously we use a lot of Go routines under the hood, right? So you can have parallel also, right? So then it's just your infra basically. So we are limited but just by our CPU and memory, right? So if you have like a very, very heavy machine, right, multiple Go routines will deploy it together. Or if you want, you can have multiple. So it's designed in such a way that you can have multiple runners also if you want, right? Because it's just a ECS task, right? So you can either spawn one or you can have 10, 20, whatever, right? So it's stateless basically. It's a client, right? Yeah.
There is a tool called Cloud Foundry. It's a PaaS basically. Like deployed to multiple clouds. Have you looked at it?
Yeah, see, there are actually many tools, right? But none of them were, when I was researching, right, none of them were, like, I wasn't happy with any one of them at that time. So I don't know, like Cloud Foundry, to be honest, I haven't tried. But for me, see, as a developer, I don't want to get into infra, right? So if a tool tells me that, okay, I want to learn Kubernetes, I want to learn ECS, there are thousands of things that you already want to learn, right? And it's not fun. To be honest, you want to build things, you want to make sure that your clients are happy, right? Rather than worrying about whether you're using, has your client ever asked you, right? EKS, ECS, whatever, right? So our main aim is that, is we want to build a developer tool, right? So I don't know there are so many Kubernetes wrappers, I've seen that. So we don't want to build that, to be honest, yeah.
So do you also plan to put something for stateful sets? Currently I really use this for applications, but
Right.
everything is stateful.
See, I'll tell you the vision, right? So in the next 3-4 months, we'll be able to deploy a Docker Compose file, kind of, right? So for example, whatever is there in Docker Compose file, because developers deal with Docker Compose files more than anything else, right? So that's what our next go-to plan is, right? Supporting something like stacks, right? So you'll be able to deploy an entire stack on this kind of a platform, right? And then I feel that'll add a lot of value to the product. Yeah.
That's right. It also has a lot of complexity because I think main thing after you deploy is the maintenance that comes out.
Right.
For example, if you want something stateful, you deploy MongoDB, then
Right.
you update it, or you
Right.
upgrade it. That would become a little tough job.
Yeah, absolutely, right. Databases is something that we'll be supporting as well, right? So there'll be two ways. You can either have a Docker file, Docker image, right, of suppose MySQL, right, with some storage, or you can have support for RDS directly, right, which is on AWS, which is directly an API call or whatever. But databases we will be supporting. So currently we are using MongoDB, right, for our own system. But we are able to use MongoDB because of environments, right? So our environment directly connects with MongoDB. So one advantage of this product is that you're not moving away from your cloud, right? So even if you have some RDS that you have manually started, right, you can still use this to deploy websites and directly just connect it using some environment variable, right? So you don't need to deploy MongoDB or RDS using this platform for now, at least. Because it's on your cloud, right? It's not like Heroku where you don't know like Heroku to AWS connection, right? So that you don't need to do. You can use the same cloud account, right? Yeah, the runner is completely open source. Yeah, you can check it out. In fact, yeah. It's written in Go, so you can. Any feedback will also be important because we are just starting up and we have to add a lot of features also. Yeah.
Actually, you should start this. Just you open it for it.
Yeah, this is open source. Yeah.
Yeah, so guys can start it, right? Do for you.
Yeah, you can take a look at it. You're like Go enthusiasts, absolutely, like raise issues and whatever, right? So that'll really help us, right? So it's any question you have, you can always ask me. Like it's there.
Okay. Any more questions for Ankit?
So it uses a lot of concurrency, right? They'll really channels and all, everything is there.
Any more questions? Okay, thank you.
Cool, thanks.